Hi and welcome to the On Maths prediction for the AQA Foundation Tier Paper 3. Enjoy! Hi, I'm Chris Gilpin and welcome to this predicted paper. So we've looked at paper 1 and paper 2, taken away all of those topics and put them to one side, and we're just focused on the topics we have left. With those topics we've created the paper 3 prediction. Now I'm going to go through the entire prediction for one set of numbers, but if you go onto onmaths.com, I'm sure the link is appearing above me as we speak, then you can do the paper as many times as you want for absolutely for free, but it changes the numbers so that you're remembering methods and not answers. So it'd be a really great tool. Maybe do it once today and then another time tomorrow and just keep practicing it. You can also sign up for free and it saves your scores, and there's a whole load of other stuff on the website as well. Now, a caveat we always say with these papers is these are a revision tool. Obviously, please do other revision as well, but these are a great way of just checking to see whereabouts you're at with your revision. So I hope this helps. If you like this video, please click like. If you want to see more from us, please click subscribe. Enjoy. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger. This is our units column. This is our tenths column. And this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660. And the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. If I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. So for this question we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction that would be 2 over 4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know two things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3 over 8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4. And I'm just looking at this original fraction here. I'm going to times them both by 4. So it would be 4 over 16. And times them both by 5. 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there, so it's that one, and we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f, and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the time sign, so this is quite a nice easy question, 10ab. Now the last one is like terms, so we've got 5x here, and we're adding 5x. And we've got a 3y here, and we're taking away a y. So when you add the 5x to the 5x, you get 10x. And when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. With stem and leaves, the tens, and sometimes the units, but mainly the tens, are in this column, and then the units go in this bit here. So, first of all, I'm going to pick the smallest number, and it's easier to do this by doing it smallest to biggest, because the units here must be in order of size. Now the order goes, the smallest go on the left hand side, and the biggest on the right hand side. However, if you're doing a stem leaf over here, the biggest go on the right hand side, the smallest go on the right hand side and the biggest go on the left hand side. Basically the smallest must be as close to the middle and the biggest must be away from the middle. Okay, so the smallest one we've got is 30, so we're going to do 30 first. Now we've got the 3 already, so we're just going to put a 0 there, and that represents 30. Then the next smallest I think is 33, so the 3 goes there. I think the next smallest is 39, so the 9 goes there. Okay, and that's the 30s done, so let's move on to 40s. 41 goes there, 43 goes there, 44, 48. And the last few, so 52 and 52, well, they're the same, so they can be next to each other, and 64. So the smallest go on the left, and then you get bigger as you go to the right, and that's really important because you need to do that to get the right marks, or to get the right correct answer. Okay, the last thing to do is the key. Now the key is just pick a value, any value. I always pick the one at the top left, but it can be any value. It doesn't even have to be a value on there. And you do 3 line 0, which I've just copied the bit I've done in the yellow, means 30. Now you might ask, why do we need that? Because it's always going to be 30. Well, not quite, because you can get ones that are 4 line 1 means 4.1, which is why these ones here aren't always going to be tens. Sometimes those will be units and you'll be writing down the decimals. So just look out for that. Now you need to have, first of all the numbers in the stem and lathe, secondly them in order, and thirdly the key. That's what the mark scheme is going to say. The easiest way to order decimals is just to put yourself a few columns down the page, and hopefully I'm going to try and get enough columns. I always end up with not enough, so if I put some extra ones in, that should suffice. And just literally put the numbers in, so 14.828, and make sure the decimal points are lined up. So 8.60 is going to be like this, and I'm going to put an extra 0 in to make them all the same length. It doesn't change the number at all. So 14.86, I'm going to put 0 in there, 14.820, and then 14.7. Now, we're starting with the smallest, so I'm looking for the smallest one first. Well, the smallest one's leaping out, because if I just look at this column, there's only one number that has a 0 there, all the rest of them have 1. So the 8.60, and I have to put the 0 because that's how it's said in the question, is definitely the smallest. So we can cross that out. That's definitely the smallest. All the other ones are tied. They're all 1 in that column. So we move over to the left, the next column, sorry, the next one to the right. So 4, 4, 4, 4, they're all tied. So I keep moving along. Okay, there's a clear loser in this one. There's a clear one that's the smallest in this one. The bottom one, 14.7. So that's definitely the next smallest. So I can cross that one out. All the other 3 have tied because they're all 8. So I move on to the next column. Now, looking at this, there's 2 2s and a 6. Now that 6 is definitely the biggest number. So I could fill that in as the biggest number. And we've just got to work out what the smaller of these remaining 2 are. Well, let's move on a column. And you can see here that 14.82 is the smallest or smaller of the 2. And so that leaves the 14.828 in that position. Now always just double check the 5 numbers you've listed are the same as in the question. That's the same. 18.60, that's the same. 14.86, that's the same. 14.82 is the same, and 14.7 is the same. You sometimes lose a mark if you haven't written exactly the same number. Same goes for when there's fractions and decimals. You've got to write down the number that it showed in the question. Alright, so the first place to start on this is to plot the points. So point A is at -3, -2. So along the corridor, and up the stairs. Well, we're going across -3 on the x-axis, which is this one here, and then we're going to go down 2 on the y-axis. So it's this one here. A really common mistake is to muddle them up. So as long as you remember you're going across and then up or down, obviously if it's negative you go down, then you should be fine. Now it says point A, so I probably should label that as A. And point B is 0, 3. It means we're not going left or right at all. We're just going to stay at 0, but we could go up 3. So it's going to be there. And point C is at 3 minus 2. So along 3, down 2. Which could be that one there. So that's point C. And it says plot and join these coordinates. So I'm just going to get my ruler and plot and join them. Well, we've plotted them, so we're just going to join them. And there we go. Makes a nice little shape there. Now, question B says, what type of triangle is ABC? So, looking at it, it looks like this length here and this length here are exactly the same length. So, when we've got a triangle with two sides the same length, it's an isosceles triangle. And try and learn the spelling of isosceles, because it does look better when you spell it right. I remember it's ISOSCELES. The SOS is like a Morse code thing to get help, save our souls. So I've always remembered SOS, as in, oh my goodness, I don't know how to spell isosceles. So we're given function machines for this question, and it says, what is the output when the input's 24? So the input's 24, and the first thing that's going to happen to it is it's going to divide by 2, so we're going to halve it. So that's going to make it 12. Then it says we're going to add 6. So when we add 6 to 12, we get 18. So the output is 18. Next question says below is a different number machine. It says when the input is 20, the output is 56. So let's follow through on the input. So the input's 20, we go take away 6, so that's going to give us 14. Now we've got to then think, right, how do I get from 14 to 56? Now, as it stands, there are multiple ways of doing this. If you do this on onmaths.com, it has a drop-down box and it only lets you select one of the options. So you can add a number to 14 to get to 56, and for this question that would be full marks, that would be absolutely fine. Or you can times it by 4, and times by 4 is the one I'm going to go for. So I'm going to complete the number machine by saying times 4. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up. But I'm going to do this in pence, so I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark. But if you actually wrote the gradient as well, then you definitely get the mark. And sometimes it will ask you for the gradient and then ask you to interpret it. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now, we've got to work out what the sizes of them are going to be. Well, the top one's easy. It's just 7 centimetres by 6 centimetres. Now, I'm not going to be able to draw this accurately because I don't have a ruler. But we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimetres, and that should be 6 centimetres. And in your exam, just make sure you actually measure them, because they are said to you in here, and it does say accurately construct. So you want to make sure that it's done 7 centimetres and 6 centimetres. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across, because it's the same as this one here. But what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimetres left over. So it's going to be 2 centimetres in width. Ooh. Let's use this one, right. So it's going to be 2 centimetres in width. So 2 centimetres there. And this one obviously is going to be 6 centimetres, the same as the right hand one. Now, this line we have in the middle, this line here, is really important, because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now, because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay. And each part, so one part, is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction, and it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. For this question, the main thing we need to remember is the triangle. Now the triangle is like the speed, distance, time triangle, but obviously this has nothing to do with speed, distance, time. The formula says that pressure equals force over area. So as long as you've got force on the top, which is measured in newtons, then you're fine, because area and pressure can be the other way around. So if we're asked to find the pressure, so we cover up pressure on the triangle, we cover that up, and it says that it's force divided by area. And it says that the force is 2280 newtons and the area is 38. So we get our calculator out, 2280 divided by 38, and I get the answer of 60. Now the units, because force is in newtons, and because area is either in meters squared or centimetres squared normally, then the units are newtons per centimetre squared. So it's 60 newtons per centimetre squared. Don't forget, it could be meters squared, newtons per metre squared, and that's absolutely fine for pressure. First thing we need to realise with this question is which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left. So 2 left. And let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4. So 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got 2 powers with the same base, which these two do because they're both A, you add the powers. Now if you think about it, A squared is A times A to the power of 6 is A times A times A times A times A times A. So in total we're timesing A by itself 8 times. So it's 8A to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. Term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimetres cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimetres cubed, because every unit is in centimetres, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1,800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. For these types of questions, always make sure that you show your working. Show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate. alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Right, so you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a liar. A liar has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a liar's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha's only got Christine left to play after we counted all the other matches. And Christine's matches have already been counted so far. So, we've got the 4 matches a liar's going to play, 3 matches that William's going to play, not counting the one we've already counted from a liar, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total, there are 10 different matches going to be played. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now, multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always. And 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now, 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now, I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to nearest penny because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to £917. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B. It needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start, and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now, this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years. And we're doing this for 2 years at £300. So first of all, I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money. So we're going to go up by 2.3%. So that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that and calculate 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018, but you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312, and I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%, and then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I round it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And then it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, so for this question we need to work out the length of the arc, which is around here. And then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's two decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bit. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Well, I hope you found that video useful. If you liked the video, please click like. If you really liked the video, please click subscribe. Please check out our website onmaths.com for some last minute revision. We've got all of the topics on there called Topic Busters. We've got quick multiple choice ones, which we have video explanations for instantly, called Minute Marks. And we've got a whole load of other stuff on the website. Thank you very much for watching.